Hello, hello. Here is the video going over the Algebra 1 Semester 2 Final Exam Review Packet, specifically Unit 5, Quadratics in Vertex Form. So, first and foremost, what is vertex form? So, vertex form is over here in this box. It is one of three forms that we can use for quadratic functions, and it's called vertex form because you can get the vertex just by looking at your equation. So my vertex is h and k, and I can pull my h and my k from that particular format. So if I look at number 15, the first thing it asks is, what is the vertex? Your vertex is the highest or the lowest point of your graph for your parabola. My highest point is at 0, 6. And since it is the highest point on my parabola, that is going to be a maximum. So if your parabola opens down, that's going to create a maximum. If your parabola opens up, that is going to create a minimum, since that would be the lowest part of your graph. Number 16, find the vertex of the function. So again, I can pull out my h and my k. And since your original form for vertex form is x minus h, that means my h for this particular function is actually negative 3, because I would need to have x minus negative 3 to create that x plus 3. And then for my k, that's going to be negative 18. So essentially, anytime you're taking out the vertex from vertex form, your x-coordinate is going to be the opposite of what you would see within that parenthesis. Okay, write the following quadratics in order from narrowest to widest. So what you're doing to compare width of quadratics is you are looking at your a value. Now, it does not matter if your a is positive or negative. The positive or negative denotes if the parabola is opening up or if it is opening down. So I'm just going to look at my a values without the negatives if it is negative. So for this one, a is going to be negative 1, but I'm just going to look at it as a 1. For my second one, a is 1/4. And for my third one, a is negative 8, but again, I'm just going to look at it as an 8, so I can compare my values from narrowest to widest. So the graph that's going to be the most narrow is going to have your highest value for a. So again, I'm not going to pay attention to that, the fact that these are negatives. That just tells me that your parabola is opening down. So the value that has the highest value for a is going to be the most narrow. So that is going to be the y equals negative 8x squared. My next highest value is going to be the next narrowest, which is going to be the y equals negative 1x squared. And finally, the widest is going to have the smallest value for a, which is that 1/4. All right, next question. Which best describes the graph of the equation y equals 3x plus 1 squared minus 10? So the first thing I want to do is I want to examine what my a is. So if I look, my a is 3. And it is positive. So since my a is positive, that means my parabola is opening up. So I can go ahead and eliminate some answer choices, since C and D are telling me that my parabola is opening down. And if my parabola is opening up, it's doing something like this, where my vertex is going to be at the very bottom. And since my vertex is at the very bottom, that is going to be a minimum. So my correct answer for this one is going to be B. For number 19, given the following tables, which of the following can be represented by a quadratic model, y equals a, x minus h squared plus k, where the vertex is a minimum. So the first thing I want to do is I want to figure out which tables actually represent a quadratic. Now, when we have a quadratic, you're going to have a little bit of symmetry because one side of your parabola matches the other. So what I'm actually going to look for first is I'm going to look for my vertex. Your vertex, if I look at my y-coordinates, your vertex will always be sandwiched between the same values. They'll be right in the middle of a sandwich. If I look at letter B, I can see that my 2, 2 is surrounded by the 1s and the negative 2, so I know both of those represent quadratics. If I look at letter C and I start to compare my y values, I can see that my y values are growing very, very quickly. If you want to, you can actually establish the pattern. It's multiplying by 4. So this actually is not a quadratic, it's an exponential function. So it's not going to be part of our answer choices as we decide which vertex is a minimum. For letter D, if I compare my y values, I can see that my y values are decreasing by 3 each time. So this is also not a quadratic. Since it's decreasing by 3 each time, that's actually a linear function. Okay, so now we're just focusing on A and B. So once again, I found my vertex for each of those, and I need to determine if it is a max or a min. Now, in order to do that, I'm actually going to plot some points. So 2, negative 3 would be over here. So there's my vertex. I'm going to go ahead and plot the surrounding points. So 1, negative 2 would be right here. 3, negative 2 is over here. And I only need 3 points to sketch a parabola, so I can go ahead and see that that parabola is opening up. I'm going to use the same idea for letter B. So for letter B, I'm going to plot my vertex. I'm going to plot it at 2, 2. And I'm going to plot some other points. So I can plot 1, 1 and 3, 1. And I can see this parabola is opening down. So again, I wanted to find where the vertex is a minimum. So if my vertex is the minimum, that is going to be at the very bottom of your parabola, which matches letter A. Your vertex for letter B is actually a maximum. Okay. Graph the following equations, identify the x-intercepts. I'm going to go ahead and start by finding my vertex. So my vertex, I'm going to take the opposite of what's in the parentheses with my k on the outside. So negative 2, 5. Can go ahead and plot a point. And then from here, I can go ahead and find my x-intercepts. In order to find my x-intercepts, I'm going to go ahead and set my equation equal to 0. Your x-intercepts occur when y is 0. So I have 0 equals x plus 2 squared minus or plus 5. And then I can go ahead and start solving for x. I'm going to subtract 5 from both sides. That gives me negative 5 equals x plus 2 quantity squared. To undo a square, I need a square root. And if you look right here, you're actually going to take the square root of a negative value. Even if you try to put that into your calculator, it's going to give you an error. So that means this actually does not have any x-intercepts. So I'm going to write none. So what does that mean for the graph? So your x-intercepts are where your graphs cross the x-axis. Since this one doesn't have any, that means it's never touching this axis at all. It's never touching that x-axis. So that means this parabola needs to open up. So there is my general sketch for that particular graph. For the next one, I'm going to do the same thing. I'm going to start by finding my vertex, h and k. So this vertex is at positive 2, negative 8. So I'm going to go to 2, negative 8, and plot a point. And I'm going to do the same thing to find my x-intercepts. That is when y equals 0. So I can go ahead and set up my equation. 0 equals 2x minus 2 squared minus 8. And I'm just going to work through that process of solving for x. I'm going to start by moving my 8 to the other side, rewriting. From here I can divide by 2. So I have 4 equals x minus 2 quantity squared. Now to undo my square, I'm going to go ahead and square root. Square root of 4 does exist. I'm going to go ahead and scooch it over a little bit since I'm running out of space. So when I take the square root of 4, that's going to give me plus or minus 2 equals x minus 2. And that plus or minus is going to allow me to find both x-intercepts to see where they graph or where they cross the x-axis. So from here, I can separate and get two equations. I have positive 2 equals x minus 2. I also have negative 2 equals x minus 2. And then I can solve both of those. So I can add 2 to both sides. This first one tells me that x equals 4. So that means I'm going to have an x-intercept at 4, 0. For my second one, I can add 2 to both sides. And this one is going to give me x equals 0. So my other x-intercept is at 0, 0. So I can go ahead and plot both of those points, 4, 0. And 0, 0. I can see that my parabola is opening up. Can go ahead and connect to draw my U-shaped graph. All right, number 21. What are the x-intercepts of the quadratic? So very similar to what we've been doing with the other question. Again, that is when y equals 0. So I'm going to plug in 0 for y. That gives me 2x minus 1 squared minus 18. Going to go ahead and add 18 to both sides. That gives me 18 equals 2 times x minus 1 squared. Still need to get rid of this 2, so I'm dividing, and I have 9 equals x minus 1 squared. From here, I can square root. Square root of 9 is 3. But of course, since we are taking the square root, it's plus or minus 3 equals x minus 1. And then I can get my two equations. 3 equals x minus 1 and negative 3 equals x minus 1. I can solve both of those. My first one is going to give me x equals 4. Second one is going to give me x equals negative 2. So I can write them as ordered pairs. So my first x-intercept is 4, 0, and my second x-intercept is negative 2, 0. Number 22, what are the y-intercepts? So your y-intercepts happen when x is 0. So now I'm going to plug in 0 for x. So I have y equals 2 times 0 minus 1 squared minus 18. And I can go ahead and simplify that expression. You can use the calculator to simplify it. Just don't forget about order of operations. And then that gives me negative 16. So my y-intercept as an ordered pair would be 0, negative 16. Okay, write the equation of the quadratic in vertex form described in the table. I'm going to go ahead and start by writing down my vertex form. Y equals a x minus h squared plus k. So I need to find two things. I need to figure out what my vertex is, and I'm also going to find a point, just any point in my table. So for my vertex, I'm looking for that sandwich again. That sandwich happens when you look at your y values and you see the same y values surrounding one of your other ones. So that is this 3, 5 over here. And I know it's the 3, 5 because my 5 is sandwiched between those 4s. So my vertex is 3, 5. For my point, I'm going to pick any point that's on my table, and I'm going to use the point 2, 4. So what you're going to do is you're going to plug in all 4 of these numbers into your vertex form. 3 is h, 5 is k, I'm going to plug in 2 for x, and 4 for y. And what that allows me to do is it allows me to actually solve for a, because we don't know what a is yet. So I can go ahead and make the substitution. So for y, I'm going to plug in 4. I don't know what a is. X is 2. H is 3. and k is 5. So just working through this, simplifying 2 minus 3 is negative 1 squared plus 5. Negative 1 squared is negative 1 times negative 1, which is just 1. So I have 1a plus 5. Subtract 5 from both sides, and you get a equals negative 1. So now that I actually know my a value, I can write my equation in vertex form. So I'm just going to replace my a, h, and k, and then that's going to give me my final equation. So I have y equals negative 1, x minus h squared plus k. And there's your equation for 23. And that was the last question for this portion of your final exam review packet, Unit 5, Quadratics in Vertex Form.